This is the summary for Lesson 7. And Lesson 7 is on similar polygons. So if you look at these two rectangles, you might just by looking at them think that they're similar. So now we have to test that by looking at the factors that take the corresponding sides to the values of the other rectangle. So if we look at this pink rectangle, and actually the first thing is to slide it over here, line up the vertex, line up the vertices with the center of dilation, and you're going to see that they don't quite line up. You cannot draw a single arrow from the center of dilation through each vertex. That tells you that it's not a dilation. You can't take this vertex to this vertex through a dilation, and vice versa. You can't take this vertex back to this vertex through a dilation. So they are not similar figures. But what is the factors that take each length to its corresponding length tell you? Well, the factor that takes 3 to 4, 3 times what value equals 4? Well, 4 is 4/3 of 3. So if you take this 3 and you divide it into 3 equal parts, each one of these is a third. This is 1/3, 2/3, 3/3. And this third over here for the 4 is the 4th third. So once again, 1/3, 2/3, 3/3, 4/3. So 4/3 of 3 equals 4. So that's the factor. It's really not a scale factor because these images are not scaled. All right, how about what takes this length 2 to this length 3? And that factor is 3/2. 3/2 of 2 equals 3. So if you take 2 and you divide it into halves, 1/2 is half of the 2. 2/2 are 2 of these units actually. And 3/2 is this third unit right here. So 3/2, if I take these two units, divide them in half, this is going to be 1/2, this is going to be 2/2, and this is going to be 3/2. So 3/2 of 2 is equal to 3. And the arithmetic shows you that these 2's cancel out, and you're left with the 3. These 3's cancel out, and you're left with the 4. But the visual image of what's going on, it's better to think of 4 as being 4/3 of 3, and it's better to think of 3 as being 3/2 of 2. Imagine cutting something into 2 parts and then taking 3 of those equal parts. That would be 3/2. All right, that all being said, these factors are different, so the factors are different. They're not scale factors because it's not scaled, just the factors are different. And if you take, this is a parallelogram and a rectangle. So if you take them, so they have equal lengths around each figure. So 3 and 2, 3, 2, but the angles are clearly different in size. So if you take this, this is a parallelogram, if you quadrilateral parallelogram, you slide over here, line up the vertex, use this as the center of dilation. You cannot take an angle from this parallelogram and dilate it to this same angle in this rectangle. Just won't work. So side lengths equal, scale factor is equal to 1. So 3 times 1 is 3, 2 times 1 is 2. You could say it's the same scale factor, but the angles are different. It's not a dilation. So you can't find a line or a ray that will go from the center of dilation through each vertex so that you could dilate them either larger or smaller and make them match, make them copy or map right on top of each other. So it's not a dilation. And so these two images are not similar. So to have similar figures, you need the angles to be congruent, and each of the side lengths have to increase or decrease by using the same scale factor. You can't use different scale factors. have to use the same scale factor. So you should be able to take one image, move it through a series of transformations and dilations, and make it exactly copy or exactly map to the second figure or the second image. Then they would be similar figures.